Okay, so first video of 2024. I've been working on a project, which is this here, a book I've been writing called Understanding Base 12 Math, How to Draw the Perfect Circle Using Dozonal Geometry. So, 7 years now I've been studying, exploring, looking at very closely base 12 geometry. So a branch of base 12 math, but the math within the geometry is in base 12. But it's not super complicated math. It's the math that emerges from the radius and diameter of circles, the lengths of lines. So it's mostly the lengths of lines that we're talking about and the circumference of circles. And so I explain the difference between base 10 and base 12, how the decimal place is the length that changes when you go from one base to the other when you're on the Cartesian plane. So it's very important to understand that we're doing geometry on the base 12 Cartesian plane. So I explain that in the book in the first couple chapters, go over the basics, and then I show the diagram that generates 360 degrees. So there's a whole bunch of steps that get us to looking at the constructing of a diagram that doesn't exist in base 10. There is no geometric structure that perfectly divides the circle into 360 degrees in base 10. So that's something to think about, to be aware of, that there's no diagram or series of steps. You can't just keep dividing all those sections in half. You miss, you're only going in halves. There's not a continuous 1, 2, 3, 4 pattern series of rings and steps where you do the whole thing in base 10, but there is in base 12, and that's what I'm showing you in this book. So this is the photocopied version. At this point, it's off at the getting our proofs back. I'm just reading through. I'm going to read you the back page just to let you know what I'm saying in sort of that hyped up back page type of way. A must-have reference for curious minds interested in understanding base 12 geometry. So simple as that. You don't have to be a math genius to understand this. And this is one of the first hurdles to overcome, is that this idea of pi being wrong. It's like such a crazy idea, and what are you thinking, and don't you know? And so it's important to remember we're talking about base 10. It's not so much pi, it's just that there's a base 10 framework and there is also a base 12 framework, and there is a difference. So that's the hurdle to overcome, is just to relax and say, okay, we know base 10 pi, we've done it, that's solid. But is there something else in base 12 that we've missed? The answer is yes. So if you just instantly negate anything outside of base 10, you're not allowing for the possibility that there's something in base 12 that's been overlooked. And unless you really look, you're not going to have seen it. So it's not like you have to take the time to really look and understand what the difference is. It's not that complicated, and the math's pretty simple. It's just taking time to honestly look. So I presented here in the book, if we were a culture that started with base 12, would anything be different? Because it's really a foundational difference. And so you would note the repercussions are there's some geometry that we've missed that would actually be introduced into the curriculum of math at a fairly early stage. It's like the square root of 2. You go over 1, up 1, hypotenuse, a squared plus b squared equals c squared. That level of math, the Pythagorean theorem, whenever you're getting into that, when you first encounter pi as the diameter divided into the circumference and just getting the basics in math, I think that's in elementary school still. So this is the level of math that we're talking about. It's just something that we've missed because it doesn't exist in base 10. So the purpose of this book is to foster an understanding of base 12 math and its applications in geometry. So again, we're focusing on geometry, which is sort of simple. It's a simpler, easy to get into. You're just drawing circles, drawing lines where the circles overlap. You get those 2 points, you connect the dots. That's all that this diagram is. It's just to realize that there's proportions in there. It's all about the ratios and to the length of 1. So what emerges is a new geometry that answers some questions that have been sort of, I wouldn't say overlooked. They were asked, an answer never really appeared, and then they just faded off because in a way they don't interfere with engineering or building, or it has to do with the square root of 2 and the definition of irrational numbers. And the fact that they just trail off into infinity isn't really a problem in the world, but it's becoming one because we're now able to track those numbers down in terms of the size of things. Again, we're talking about lengths and distances. We can go a lot of decimal places and find something really small. So what's the connection of the square root of 2 to actual physics? This is the question that comes up, because once a pattern emerges, it gives the possibility of some structure to small units, small geometric shapes. That sounds a bit vague, but within a lot of empty space. So this geometry takes into account the empty space that we haven't really acknowledged. And the reason we've done that is we've created a model of the line that is solid. And then when we encounter irrational numbers, we say, well, there's a little gap at the end between where the line ends and where it lands on the x-axis. And so this is the looking for the right word, the challenge in understanding what that number is. Why is it like that? What does it represent? So what I've realized is that irrational numbers represent the world that we live in, the physical universe that contains empty space. And so it's the empty space that allows for the number to go on forever. Our model of solid with a little gap at the end is a wrong model. That empty space is dispersed throughout. And so when you do that, you have little sections of line. This is quantum, little sections of line, like a dotted line in a way, or a dashed line. Those little sections are ultimately the diameters of something. So this is the circle, the tiniest, smallest unit. This geometry gives us that.